Hello, everyone. My name is Song Wei. I'm come from Xuzhou University of Technology. It is with great pleasure that I'm presenting this talk today in the conference. The focus of my talk will be on the very high cycle fatigue property of stainless steel for compressor valve plants. Um, Meanwhile, I'd like to acknowledge the support of the funding of fundamental agency and the industry partners. This part included four parts. The first is about motivation, and second is the fatigue experiments details, and the third is the test result. Fourth is the conclusions. Uh, Uh, the background and the motivations for the work is study the reliability uh, assessment of air conditioning compressor. We can see from the picture the valve allows from the allows the gas flow from and to the cylinder area based on the pressure difference, while it could block airflow from the opposite direction. It opens when the pressure below the valve exceeds the pressure above, plus the spring force. During the operation of the compressor, the valve plane will be subjected to cyclic impact and bending loading in the air condition. So the valve plane is a critical component in the air condition compressor. According to the statistic analysis of the component in air condition compressor, the cycle number is larger than the 10 million cycles. Then that is belongs to very high cycle fatigue under the cyclic bending. The valve is made by the maximum magnetic stainless steel. So the problem of the valve plant is that there is no enough fatigue data for the very high cycle fatigue under different loading condition, including the origination of the specimen, extracted specimen. So uh, the our purpose in the study is that to get the very high cycle fatigue property of a magnetic stainless steel. So we can own some applications of this study in the future. The first one mm, is the quantitative assessment of very high cycle fatigue of materials for the valve plan. The second is to improve the structural reliability of air conditioning compressor. Um, so this is about the details of the specimen and the fatigue test. We extracted the specimen from the parallel and the vertical with the rolling direction of the material. And the fatigue test, the loading is a bending cyclic loading, and the test frequency is about 20 key HD, and the stress ratio is about uh, negative 1, and the failure criterion is complete breakage. So uh, we use the different in order to simulate uh, the processing of the fatigue, uh, ultrasonic fatigue processing. So we use the Euler Bernoulli beam theory and combining with the boundary condition and the displacement, we can get the deflection loading, and the maximum stress. According to the simulation, and from the result of the bending fatigue test, we can see that the final location is lied on the end of the cantilever due to the larger stress concentration for this specimen. And according to the simulation setting in the ABAX software, the elastic modulus will affect the vibration of the beam mechanical response. So different elastic modulus was employed to calculate the stress vibration of the beam fixed end. The slightest vibration is the case using 280 gigapascal elastic modulus according to the actual stress response. Then we can get the SN curves by the static calculation method and dynamic method. And according to the results, there is no difference for the specimen with two different directions. And comparing B and D, and we can see that the SN result by the static calculations method show more dispersion for the test data of fatigue life than those calculated by the dynamic method. So this is the conclusion. The fractal locations of the sample with different extracted directions are the same, and the specimen extracted direction show a slight difference for the material fatigue strength. And according to the mechanical response by the dynamic method, the elastic modulus can induce some vibration of the stress values by the combination with the natural frequency of the sample and the actual loading frequency. The optimization value of elastic modulus was utilized to simulate the stress response. And the third is SN curve. SN results by the static calculation method show most despair than the dynamic method. Thank you for your attention.